My name is Sharmila Akhtar. The last four digits of my student ID is 1246. The topic of my presentation is process synchronization. A discussion topic: process synchronization, common synchronization problem, procedure, consumer problem, critical section problem, mutex, semaphore, boundary buffer problem, binding philosopher problem. Process synchronization. What is process synchronization? Process synchronization ensures that multiple processes coordinate execution in a way that avoids conflicts while accessing shared resources, memory files, or variables. Why is process synchronization needed? Prevents race conditions, ensure data consistency across processes, avoid deadlock, prevents starvation. Common synchronization problems: race condition, deadlock, starvation, priority inversion. Procedure consumer problem. The procedure consumer problem is a classic synchronization problem in operating system and concurrent programming. There are two types of processes. Producer generates data and adds it to a shared buffer. Consumer removes data from the shared buffer processing. Case analysis. Synchronization. Ensure procedures and consumer don't access the buffer at the same time in an unsafe way. Buffer overflow. Preventing procedures from adding more data. Buffer underflow. Preventing consumer from trying to remove data. Solution using mutex and semaphores. To solve these issues, we use mutex, virtual exclusion, blocks, and semaphore counters for resource control. A mutex ensures only one process accesses the buffer at a time. Two semaphores are used. Empty tracks the number of empty slots in the buffer. Full tracks the number of filled slots in the buffer. Critical section problem. The critical section problem occurs in concurrent programming when multiple processes or threads access shared resources simultaneously, leading to race condition and data consistency. Synchronization tools. Mutex, a binary log allowing only one process at a time. Semaphore uses integer counters to manage multiple resources. Mutex and semaphore explanation. Mutex and semaphore are synchronization mechanisms used in concurrent programming to manage access to shared resources and prevent race conditions. What is a mutex? Mutex is a blocking mechanism that allows only one process or thread to access a shared resources at a time. Characteristics of mutex. Binary lock. Only one process can own the mutex at a time. Must be a simplicity released by the process that unlocked it. What is a semaphore? A semaphore is a signaling mechanism that controls access to shared resources using counters. Types of semaphores: binary semaphore, counting semaphore. Characteristic of semaphore: can allow multiple processes to access a resource. Can be used for process synchronization. Key difference between mutex and semaphore. Mutex locking mechanism. Only one process can access. Process that locks must unlock. Mutual exclusion. Binary. Semaphore signaling mechanism can allow multiple processes. No strict ownership. Process synchronization. Bounded buffer problem. What is the bounded buffer problem? The bounded buffer problem is a classic synchronization problem where multiple procedure and consumer shared a fixed size buffer. Procedure generate data and place it in the buffer. Consumer take data from the buffer and process it. Challenges in the bounded buffer synchronization. Ensure procedure and consumer do not access the buffer simultaneously. Avoid buffer overflow. Preventing procedure from adding data when the buffer is full. Avoiding buffer underflow. Preventing consumer from taking data when the buffer is empty. Solution using Semper and Mutex. When use the synchronization mechanisms to solve this problem. Mutex ensure only one process access the buffer at a time. Empty Semper keeps tracks of available empty slots in the buffer. Dining philosopher problem. What is the dining philosopher problem? A dining philosopher problem is a classic synchronization problem that illustrates the challenge of avoiding deadlock and resource starvation in concurrent programming. This is the scenario. There are five philosophers sitting around a circular dining table. Each philosopher alternates between thinking and eating. There are five chopsticks, and each philosopher needs two chopsticks to eat. Problem to solve. Deadlock. If all philosophers pick up their left chopstick at the same time, they will all wait forever for their right chopstick. Starvation. Some philosophers might never get a chance to eat if their others keep using the chopsticks. Conclusion. Process synchronization is fundamental for ensuring safe, efficient, and reliable execution of concurrent process in a system. The common synchronization problem like procedure consumer. Critical section, boundar, buffer, and dining philosopher highlight the complexity of managing shared resources and coordinating multiple processes. Text and Symforce are essential tools for ensuring mutual exclusion, preventing deadlock, and handling access to shared resources effectively. Understanding and solving this synchronization problem is crucial. Building robust and multi-threaded and parallel system that can operate correctly without conflicts. Thank you.